All right, so this over here is what we call a prototyping breadboard. All right, it looks because it's in rows, it looks like a bunch of sliced bread, but this is what we use to test our circuits before. Yeah, before we solder it, before we actually make the circuit board, because we can easily pull stuff out and push it back in. The basic understanding of how these breadboards work is you have down the middle you have these 5 rows. If that's going to focus, we have A, B, C, D, E, and then F, G, H, I, J. And then across the top, so, which would be columns, we go from 1. It's going to be blurry over here. But we go from 1, imagine it's not blurry. We go from 1 all the way down to like 60. All the letters, so A to E, are all one common piece of metal. All right. So if I'm pointing over here, if I'm plugging into this A over here, A, B, C, D, E, these are all the same row. So A1 connects to A1 connects to E1. A2 connects to E2. Right. So every column is there's a common piece of metal connecting every column together. Along the top and bottom, you have this positive and negative. They means that all these positives are all connected together, and all the negatives are connected together. In the middle of the prototyping board, you have a larger gap. This gap is not connected together. I can't show it underneath. So you need to find some way to connect these two together, which I've done over here. But then that means if I get this whole positive over here, I can connect something to the positive line over here, or something to the positive line over here, and it can give you positive voltage to the whole circuit. And then I get some cables, like I have this blue cable over here connecting this negative over here to this negative over here. So I can easily access the positive and negative of the circuit. I wonder if I can get even closer. Even better. All right. So how this circuit works, we have the HT12E over here, the encoder, which is a bunch away from all these wires. The HT12E is over here. We have the HT12D over here. These two circuits are only connected by this blue wire. So not this one, not the blue wire, this yellow wire. This yellow wire is the only thing connecting these two circuits together. So if I actually move them apart, you can see the only thing that's actually connecting these two circuits together is this yellow wire. In your full circuit, this will connect to your wireless transmitter or whatever, but in this case, the data is going to be sent by this one wire over here. We have 4 buttons, and we have 4 LEDs, we have resistors, and so what's going to happen is as I press one of these buttons, if I press this first button over here, this first light should light up. Right, this lights up, and then if I can reach to the second button, second light, third, and fourth. And you can even do them in combination. So you can do the first and fourth. Right, this is going to be how you're going to control your car. So if you want the left and right motor to go forwards, you would press the forward operation on the left and right motor, like these two to go forwards. If you want them to go backwards, you're going to press the backwards with the left and right motor. Alright, so how do we get to this stage? I am going to unplug everything and show you how we're going to get this circuit loaded up. And hopefully, remember how everything goes here, so that's going to be easier for you. So let's take all these out. But I'm going to keep the resistors in. Can you turn the power off? All right. So, as you see over here, we have I want that to unblur again. You can't see the model number. This is the HT12E. This is the HT12D. If you get the data sheets, for these particular encoders, this is the encoder data sheet. if you look on page, I guess it's on page 2, we have this over here being our data sheet that we need, and it has all the relevant pin locations that matter for our circuit. So the most important ones we need is VDD and VSS, that is our positive voltage and our negative voltage. Over here in the circuit, I haven't unplugged everything. If this is where I'm going to have my positive voltage, I have positive over here, connects to this yellow wire over here. So up here, I have positive over here. So I need this, I need somewhere on this positive line over here to connect to pin number 18. That's the VSS. VDD. Yeah, VDD is positive. VDD is positive. So I need to connect these pins over here. So I'm going to get one of these pins. Now these are wires that are, the ends of them are hard. Right? Do not solder these wires because they're really, really hard. They're designed to push into these breadboards. Right? When you are working on your circuit boards with your copper, you can get any wire and you can solder it onto your copper circuit boards. But these are used just for these prototyping boards. So if I go here and I plug this into this pin over here, this should be powered now, and I can do the same thing when I look at my circuit diagram. I see where my negative is. I have VSS for negative. So let's find any wire that I want. And let's say I just do this over here. I'm going to connect that to negative. So this first chip over here has its positive and negative power. I'm going to do the same thing with the chip at the bottom. I didn't actually unplug this before, but this is our negative power for it. And we can get our positive power as well by going like this. All right, so now the next things that we need for the chip is, over here we have A0, 1, 2, 3, 4, 5, 6, 7. Is it not flipped? Oh, it is, yes. A1, 2, 3, 4, 5, 6, 7. This is your address pin. This is, if you're doing like a garage door, you can have your certain garage doors on a certain code, and so all that matters is the address pin has to match the same code on the receiver. In this case over here, because I don't want to waste the wires, I'm just going to have nothing connected to my address pins on either of my circuits. So we don't need anything else on this side of the pin. Nothing else over here. So let's deal with this side over here. We have our VDD. We have our D out. That is our data pin. And so I'm just going to plug the yellow data pin in. And then when we look at the data sheet for the decoder, we'll see where we have to plug that. We have our oscillator. Now our oscillator, we have this resistor over here. If we look on the table, so pins number 16 and 15 are the two oscillator pins. And they relate to this resistor over here. If we look on the table on page, if we look on the table on this page over here, we have the table relating to what frequency our oscillator is going to be at. So I don't remember exactly what size resistor it is, but we have to make them match. So for this particular circuit, we're trying to run it at 15 volts. I think it's a 1 mil resistor, so I think it's at 3000 kilohertz. So when I do my receiver, I have to make sure it's also at 3 kilohertz. So you have to make sure your two resistors match, especially if you're going to be doing a different voltage for the car and the controller. In this case, they're both on 5 volts. When we go back to the diagram, after the oscillator, we have TE. TE stands for transmit enable. So this means if this is connected to ground, then your circuit will work. Right? It's going to be transmitting the information. If you do not connect this, it's not going to be sending any information at all. This can be used, I'm not sure, I can't think off the top of my head an example where this would be used, but you might be, if you imagine if you have a remote control car, you could be having like, this could be the off button, right? Or you might want to test your circuit before you're actually outputting the information to a radio receiver. So in our case, we always want to have this connected because we always want to be transmitting a signal. And just so I don't make a mistake, I think it just connects straight to the circuit. Yeah, so we want this to be connected to ground. So let's get a pin over here. We want this to be connected to ground, so let's plug into this pin over here. I'll just connect you to ground. All right, so transmit enable. Next we have, we just have a bunch of these resistors. For this example, I'm going to plug these resistors out for now, right? And we're going to try to do this without using any of the buttons just to get this circuit to work to begin with. Let's look at the circuit diagram for the receiving chip. So it has a slightly different pin configuration. The HT12D over here has a slightly different pin configuration. The entire, what's that, the left side? The left side is all the same. The left side is exactly the same, going from address 0 to address 7 and the voltage, ground voltage. All right, but then if we look at the right side, we start with our positive voltage, which is fine. We have VT, which our VT is, you plug a, this is where you can plug like an LED light, and it tells you if that light is on, it means it's getting, I believe it's getting an input signal. Right, yeah, it says it's getting a valid transmission, if you look on this sheet over here. So why this is relevant, if all your inputs are turned off, so like you have none of your motors working, you can still plug an LED light up to VT and it tells you that you're still actually connected to the controller. Otherwise you have no way of knowing that you're actually connected if you're still actually receiving a signal from the controller. Then we have the same, we have oscillator 1, oscillator 2, and the resistor is not going to be the same size. So we're going to have to look at the table again to make sure we have the same frequency. Then we have D in, this is our data in, which is on pin number 15. So when we have a look at this pin over here, this yellow pin, we're going to go to pin number 15, which is right after the resistor. The pin right after the resistor. Yeah, no, I want it to focus. Come on. There you go. The pin right after the resistor over here. And then we have a bunch of, we have all the outputs from outputs D11 to D8. And I just connected them through a resistor to get to the LED lights. So it looks a bit weird because it's overlapping, but don't have a pen. For example, this pin over here, can someone get me a pencil from the board? There's a pencil from like the rack. So this pin over here outputs to this resistor. Come on. Yeah, can you stop bumping the table, please? All right, so this pin over here connects to this resistor. This resistor is connected to the feet of one of these LED lights. Because if we look over here, this is row number 35. Row number 35 is connected to this resistor over here, and it is connected to the foot of this LED light, and then the LED light is at the end connected to ground. So, and I'll let you get some zoomed in pictures of this later, but so basically these four resistors are used so they don't blow up these LED lights because we're running at 5 volts. So if I plug this in now, can you give me voltage now?
You took out the resistors.
Yeah, no, I know. So okay, so we have voltage right now. So let's have a look at how this circuit actually works. There is an example circuit diagram on one of these pages. there is an example circuit diagram on this page over here for HT12E. Let's line that up. There we go. HT12E. And over here we have all our address pins, which we don't really care about. We have our ground, which is over here. We have our VDD voltage, which we have connected because we have power going through our circuit. Our D out is going to our transmitter. Instead of it being a transmitter, we're just connecting to this yellow wire over here. Our oscillator is connected, that's good. Our transmit enable is connected to ground, so in theory that should all be working. Now these are our switches. Notice in this diagram we have these switches. As these switches are connected to ground, it's going to be affecting these lights. So if I just get one of these switches, so let's say I want the second light, so I'm connecting up to pin number 12. Right, I just plug into pin number 12. If I connect this pin to ground, we should see a change in one of the lights. Woo! Genius. Right, so right now, if I ground this pin, I'm changing the lights. And to show that this actually works, if I disconnect the transmit thing, it's not changing the response. Alright, so let's go back to transmitting. So I can change that ground. If I change another pin, so I just want to check that all my pins are working. So if I do this pin over here, we have the first light is off, second light, third light, fourth light. And then we can go to the next step where instead of it doing it through a manually plugging in a wire, we're going to get it to get one of these buttons to work. So all we want to do is get these buttons to basically connect the circuit to ground. So I believe I just plug in the button. I'm plugging in over here and over here. Right, so I think this is going to work. Yes. So all that changes. I connected. This is the output pin. It's nothing showing up on camera. This over here is the output pin. I connected the output pin. We follow the blue wire. It's connected to the switch, and then the green part is on the other side of the switch, is connected to the ground. So, and then as I'm pressing this button, I'm turning the lights off. All right. So, and then we can do that for all the other. We can do that for the other 4 buttons. The problem we have here. How is this different than the setup that I had at the start of the tutorial? Yes.
At the start of the tutorial, none of the lights were on, and when you press the button, the light would turn on.
Yeah. So, how is the car going to be? What would the car be doing right now?
Everything on.
Everything's on.
Which you just cancel out, so it won't be.
Which is not what we want, right? We want to, when we push a button, for that part of the motor to turn on. So we need to change how this car is working. So, if we look over here on the diagram is saying that when we connect here, it is going to ground. That is going to activate the light. So what we can do is we're still going to connect this to ground. So we're going to do it the other way around. So we want to, so this over here is an IC chip, and IC chips work by having high and low states, where high is a state that's of high voltage and low is a state that is of low voltage. So if we are connecting one of the pins to ground, we are giving it a low state. So low state is going to turn these lights on. So we want to have our switch set up so when we press the switch,
It's turning into a low state.
yeah, the other way around. When we press the switch, it is going to go to a high state, and when we haven't pressed the switch, it is going to go to a low. So when we're not doing anything, it's going to be on a low state. Right? That is where we use these resistors. We plug in a resistor. If we plug in a resistor to here, we plug in a resistor over here, and then we want our just in case I'm wrong. So if we have this is this right now is connected to positive, and then I believe if I do plug this to... No, that's still not working. Pause the video. I hope I didn't get your name. We're recording. Okay. All right. So high and low state. So what we're going to do here is right now we want it to be negative. All right. So we are just going to plug in a resistor between the negative and the pin. So there is still a resistor here, which means that the light is turned off. And this is our first light we have over here. So instead of us letting the button go straight to negative, now we are going to connect our button in between the resistor and the whatever it is, the decade, not the decade counter, the encoder. And so what our button is doing here, right? Our button, once we're going to link our button, we have a direct wire between the output, sorry, the pin that is measuring whatever it is, I forgot what it's called, the data pin, right? We're connecting it straight to positive, which is a high state. So it should be, when it's high, the light will be on. When it's low, the light will be off. So if I press this button over here, this first light should go on. Yes. So this is the big part. Because everything else you've done so far, you're following this exact circuit diagram, right? You're just trying to get it working on like this breadboard situation. But this is the first thing you're doing where you're changing what this diagram looks like. So I'll go over that difference again. You are connecting the data pin with a resistor. I don't think the size of the resistor matters. You just want a resistor. But you're connecting it with a resistor to the negative, right? So if this switch is open, the only thing it's connected to is through a resistor to the negative. So that is going to be a low situation. But then in between the resistor and the chip, you are going to be connecting your switch. So this diagram, let's see if I can draw this upside down. So you have your ground over here, right? And then you're going to have your resistors over here. I don't know what... Ooh. Your resistor is over here. You are then connecting your switch over here. Right, and this switch is connected to a positive voltage. And then this is going to be like the output of your IC chip. No? This is close enough. The C is the wrong way around. All right. Anyway, I'm upside down. But so you have your IC chip over here. It's connected to the switch. So what's going to happen is when the switch is open, it's only connected to ground. But as soon as I close this switch, it's going to be connected to this positive voltage. Right? And that's what you're doing for all 4 of these switches. And I'm not going to bother plugging all the rest of them in because it's just copy pasting. It's just going to make the thing look more confusing. And then you can also do things. I have here 4 LED lights. You can also choose to change the colors of them. When you do your task, the first thing you're going to have to do before I give you any of the circuit material is you're going to have to build one of these. Right? And you get to use the power supply. And I think I'll give you another theory lesson another day where I'm going to show you what the output looks like on the oscilloscope. But I think this is more than enough for today.